All right, we are live right now. We are live on YouTube. Sorry for the delay. I went to carry my mic. I forgot my mic, so I'll be setting up my mic right now before I go to the board. So basically, we'll be discussing about empirical formula. But before we go to empirical formula, we'll be starting with our we're starting with our separation technique. So after the separation technique, before we go on to our empirical and molecular formula. So what we have here today is chemistry made easy on um, separation technique, because when it comes to separation technique, this is a very serious topic that chemistry, or yes, this is a very serious topic in chemistry that you cannot miss, right? So this is a very serious topic you cannot miss when it comes to chemistry. This concept known as the separation technique is very, very essential that you get an understanding about this particular topic that is known as the separation technique. It's known as the separation or technique, right? So I'm facing like I'm open, so I will not be saying the messages that will be dropping, but as I teach, if you have any message that you want to drop, please drop it so that if I teach, I'll go back to check the messages that are there, and I also see I can answer it. If you have any question, also feel free to drop it, because we'll be talking about the separation techniques. We'll be talking about separation techniques. I've been always been feeling reluctant to do this, but I just feel like no, because I'm back from school. So I just feel like no need of delaying. Let me just make this video as soon as possible, because procrastination is the killer of time, is the killer of destiny. What you can do now, anything you can do now, I don't think there's any need of keeping it, postponing it till the later time. So let's talk about this separation techniques. But the truth of the matter is that you cannot just start talking about separation technique without talking about the nature of matter. So before you talk about separation technique, you have to first of all talk about the nature of matter. You have to first of all talk about the nature of what matter, right? So now when we want to talk about the nature of matter, we have to first of all, before we talk about a nature, before we talk about nature of something, right? That means what is that thing all about? You have to first of all know what that thing is before you start talking about it, right? So you have to first of all talk about what matter is all about first before we now talk about the nature of the word matter. So now what is matter? Right? Matter is something that we know right from our secondary school days. We have been hearing about matter, 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 and we know that matter is anything that has weight and occupy what space. So you see, matter is anything that has what, that has weight, and what, occupy what space, that has weight and occupy what space, right? This is our elementary definition of what matter, anything that has what weight and occupy what space. Also, as you continue advancing, you get to find that matter is not just anything that has weight, but matter is anything that has what mass, because mass can be what quantified, right? The mass of an object can be what quantified, right? So matter is anything that has weight and occupy space. You are correct. Matter is anything that has mass and occupy what space. You are correct. Also, you can say matter is anything that has mass and occupy a field, right? So you can say a field, right? You are also what correct. But it's just that as you advance, so is your addiction supposed to also what advance. So when you talk about matter, that anything that has mass and occupy a field, or anything that has weight and occupy what space, right? Now from here we have to talk about the nature of what this matter. You have to talk about the properties of this what matter, right? The properties, that is the nature, what it contains, right? So when we talk about the properties of matter, so when we say properties of matter, when we say properties of matter, right? So basically we have two properties of what matter. We have the one, number one, which is what the physical properties. We have the physical properties, right? And we also have the word chemical properties. We also have the chemical property. So we have the physical properties and we also have the what chemical what properties. Now when it comes to the physical properties and the chemical properties, this is like when we say physical, this is like physical stuff, right? Physical, like the physical stuff we can see with our eye, and the chemical is those ones that we cannot see. They're those ones that takes place what chemically, right? The chemical what properties. Now this physical properties is associated with physical what change. So this physical property is associated with what physical what change, right? And the chemical property is also associated with what chemical what change, right? So let me see whether I have any message. You have any message, right? Oh man, I have message. Please just drop in your comments. Let me know if you are following, if you are enjoying the class. Please just drop in your comments. So now, if we have the properties of matter, we have the physical properties, which can also be known as the word physical word change, right? And the chemical properties, which is also known as the word chemical word change. Now, what is the physical change? What is the word chemical word change? Right now, before I talk about the physical change and the chemical change, I want to give you an illustration that will start giving you an understanding of what the physical change is all about and what the chemical change is all about. Let's say you bought your what salt, you buy a packet of what salt. It's like I have a salt there. I'm shooting this video in my kitchen. This is my kitchen space. If I have to show you, this is my kitchen space. So I have my salt there. So let's say you buy a packet of salt, right? And you fish a cup of water, right? And you put that salt, right? You put that word salt in that word. Yes, let me use salt. Or no, if I want to use salt, I will go far because I'm already talking. If I use salt, I will jump from this nature of matter to the separation technique. So let me not bring in the salt first. I'm going to use this analogy. So just keep in your mind that I'll be talking about salt. And in case I forget, please drop it in the comment section. Remind me that, oh, you wanted to say something about salt. So talking about the physical properties, let me talk about the changes, the properties of matter before we go to the separation technique. So now, let's say you fish a water and you put in a rubber, right? In a let's say Coke water, like you fish water put in a Coke bottle and you put it in the fridge, right? Now, if you put it in the fridge with constant light, your fridge is on, you get to find out that after some hours, based on the way your fridge is, or after some hours or after some days, based on how your fridge is, that water is going to what freeze, right? So let me clean this. Let me clean this, right? So let me clean this, all of this. So that water is going to what, get what is, right? Now, when that water gets freeze, the water is going to what, get what freeze. If I remove that water from the fridge and I leave it for some time, it's going to turn back to what, liquid, right? When it's in the fridge, it's going to turn to solid. When it's out of the fridge, it's going to turn to what, liquid. But the main thing is that that water is still what, the same what, water. You get that water is still the same what, water. So freezing of water, when you freeze a water, it's going to give you solid water, right? But if you leave it and you apply it, it's going to also turn to what, liquid water. It's going to turn to liquid, right? So that is to tell you that this physical change that you just experienced, for this one you are seeing it with your eye, it's something you are seeing with your eye. So this physical change is something that can be reversed, right? It can be what, reversed, and no new substances are what formed. There's no how you can put your water in the fridge. Let me carry my pure water. I want to show you an example. Let me carry pure water, for example. So this is my pure water. Like I say, I'm in the kitchen. So this is my pure water. Eh? There's no how. Please, if you're enjoying this class, please just comment. Let me know. So this is my pure water. There's no how I can carry this pure water and put in the fridge after 3 days, and this pure water will turn to Coke, or this pure water will turn to ever wine, or this pure water will turn to any alcoholic drink. This pure water is still going to remain what, pure water forever, right? But the only problem there is that, or the only thing there is that, if I put it in the fridge, it's going to freeze. But if I remove it from the fridge and I keep it outside for some period of time, it's still going to come back like this, right? So at this particular point in time, no new substances are what, formed. So that is the same thing with the word physical word change. So when we say the physical word change, right? This change, in this type of change, it is what, it is reversible. It is reversible, and no new substance, and no new substances are what, formed, and no new substances are what, formed. So this water, if you like, it should stay 1 million years, it's still going to remain what, water. So let me keep this and bring my lighter and another thing now to show you. Wait, let me bring my lighter. I want to show you another example, right? So let me show you another example right now. Let me show you another example, right? Okay, this is my lighter. Okay, I have this. This is waterproof. So I have my waterproof here. So this is for physical change. Example of a physical change is what? Example is what? Freezing of what? Water. Freezing of what? Water. Now let's talk about the chemical what change. In the chemical change, it is what irreversible and new substances are what formed. Um, let's say this is my uh, what do you call it? This is my waterproof, right? This is my lighter. So I want to burn this waterproof now. See, oh, I am burning this waterproof. Now, me burning this waterproof, right? Me, I burn this waterproof. There is no how or there is no magic I can do right now to get back this waterproof to be the same way it used to what be. So this means that this process or what I have done right now, it is what irreversible. It is just like for those of us, I know some of you have not been to a village before, but if you have been to a village, if you have used firewood to cook before, you find out that you gather your firewood, you set fire, right? After the firewood will burn and turn to what? Ashes. There is no magic. There's nothing. In fact, I've never heard it before that you gather your ashes and you turn it back to firewood. So burning of firewood is an example of what a chemical what change. Now, when we say chemical change, we say what chemical what change. Chemical what change. In the chemical change, it is what irreversible. It is irreversible. You can never reverse it. It is irreversible, and new substances are formed. And new substances are what formed. That is example burning of firewood toward ashes. Burning of firewood toward ashes. You burn your firewood to ashes, you can never get back the firewood. That means it is not what reversible, and a new substance is formed, which is the what ashes. So let me go and keep my lighter because I'm in my kitchen, like I said. I'm coming. Let me drop it. I'm coming. All right. So I am here. I'm here. All right. So that is just how what it is, right? That is that. Sorry. That is just how it is. So we have the physical change. Please take note of this. We have the physical change and we have the chemical will change. People, you people are watching me. I know people are watching me. Please just drop your comments. When I see a comment, it encourages me to, to continue to show that people are really understanding me. And if you are not understanding me, please feel free. It's just the both of us. It's just between us. Drop your question in the comment section and I'll be very happy. I'll be very glad to answer it. So we are done with the properties, which is the what physical properties and the chemical properties, which is associated with the what physical change and the chemical what change, which I have written here down. Right. So from here, we will be talking, since we have talked about matter, right? From here now, we'll be talking about what is an element, what is compound, and what is what? Mixture. So this is the next thing we'll be talking about. Element, compound, and what? Mixtures. What is an element? Oh, elements, hydrogen, helium, lithium, beryllium. Yes, you are correct. Calcium, yes, you are correct. But the question is, what is the definition of elements? If you ask a lot of students that question, you see them checking element can't get definition. Yes, element has what? A definition. And we are going to be touching them. So we find out that from here, when we touch them, it is our understanding of what element is, it's our understanding of what compound is, it's our understanding of what a mixture is that will now push us ahead to now talk about separation what technique. Are you getting me? Right? So let's talk about what is an element. Now, element, so let me write here. Element, I hope you can see the box. Elements, this is a substance. This is what? A substance which cannot be split. This is a substance which cannot be split. Which cannot be what? Split. Sorry. Which cannot be split. That's SP. Which cannot be split into simpler substances or into simpler unit. Let me use unit. A substance unit. Let me use unit. Into simpler unit by an ordinary chemical process. by an ordinary chemical what process. So this is the definition of what an element. Take it so that in case someone is asking you, you say, oh, elements is a substance. Now cannot divide element into what simpler what unit by into simpler unit by ordinary chemical what process. Now this is what an element is: a substance. Hydrogen is a substance, helium is a substance, lithium, beryllium, boron, carbon, oxygen, fluorine, neon. Mention them: calcium, manganese, argon, gold. Mention, just mention, right? These are all what elements, right? And it cannot be split into simpler units by an ordinary chemical what process. Currently, right now, as of the time I'm making this video, this is I'm making this video on the 30th. Today is 30th of July 2025. We basically have 109 elements. We have how many? 109 what? Elements. We have how many? 109 elements. Please take note of this, especially those of you that are still in secondary school, preparing for JAM, post-UTM. These are basic questions. WAEC. These are the questions they will ask you. Be like, maybe first we'll get 20 elements. No. We have first 20 elements, but we have a total of what? 109 what? Elements. Please, I hope you people are following up the class. Right? It's very important. Please follow up the class. All right, I have someone, Antonio. Anthony, thank you for joining my live stream section. Thank you for joining my live stream section. So we say element, this is a substance which cannot be split into simpler units by an ordinary chemical work process. And I said, as of the time you are watching this video with me right now, we have 109 word element. Please take note of that. So I'm going to clean elements, and we are going to talk about what a compound. You know, back then, when I was still small, when I was still growing up, I used to hear my brothers that were already in the secondary school, yes, SS1, higher secondary school, that is the senior secondary school. They should talk about compound. I would be like, you should be compound again. Now, compound, is it not where people live? That used to be my mindset. Like, is it not where people live, right? That is what a compound is. Please subscribe to my YouTube channel. Please subscribe, so that I will feel motivated. Please subscribe. Thank you so much. So, compound, right? So what is what a compound? The question is, what is what a compound, right? That is a question. What is a compound? Now, a compound is what a combination of also a compound. This is a combination. A compound can be a combination of two elements. It can be a combination of three elements. It can be a combination of four elements. So a compound is a combination of two or more. Is a combination of two or more elements. Now, it's a combination of what? Two or more elements, right? It's not now. Okay, come now. Let me and you combine. It's more than just a combination. It's a combination of two or more elements chemically. Full stop. So we can paraphrase this by saying it's a combination of two, or is a chemical combination of two or more elements. Things like compound like sodium chloride, H2SO4, CaCO3. These are all compounds. This is calcium, this is carbon, this is oxygen. This is oxygen, this is sulfur, this is hydrogen. This is chlorine, this is sodium. So is the addition, it's like addition, or is a combination, is a coming together of two or more elements chemically. So they must be chemically combined, right? So they must be chemically combined. Please take note. And if you are following up, please drop it in the comment section so that we know that people are following me up, and I will be so happy. And please don't forget to subscribe, right? So we are done with a compound. Please take note. Is a combination, is a chemical combination of two or more elements, or is a combination of two or more elements chemically, right? So let's move on to a mixture. Mix. When we say to mix something, that means you are putting one thing, you are putting another thing, you are putting one thing, you are putting another thing, right? So we are mixing. Let's say we want to mix water and ethanol, right? So when you put ethanol, you put your water. It's a mixture, right? So let's talk about a mixture, right? Now, a mixture, right? A mixture can also be the coming together of two or more elements, right? So you can say it's the coming together of two or more elements. Yes. Should I say coming together of two or more elements? Should I say coming together of two or more elements? Should I use coming together of two or more elements? Yes. Which can easily, I will not use element. Is a coming together of two or more substance. Let me not implicate myself by using element. Is a coming together of two or more substance which can easily be separated by physical method or physical means. Have you seen? That is why I said we have to first of all talk about the nature of matter when we talk about properties of matter and element, compound, and mixture before we start talking about the separation technique. Because you have seen it that coming together of two or more substances which can easily be separated by physical method is what? A mixture. Please take note of all these things that I am saying. Please and please take note of it. It's very, very essential. So after getting all of this now, after getting the definition of what this is all about, let's talk about separation technique. Let's talk about the separation technique. If you want me, if you want me to be your special tutor, if you're preparing for any exam, post-UTME, your WAEC, your NECO, your JAM UTME, and you want to register in my class, feel free to chat me up. Feel free to chat me up. You can even request my number. There was a time I dropped my number and I got an influx of messages. I got really, really tired of because of trying to join people to my WhatsApp group and stuff like that. This is my WhatsApp number 07062462746. Chat me up and you'll be enrolled in our private WhatsApp classes. When you join our WhatsApp classes, you get access to timely clarifications from our tutors. You also get access to materials for your jam preparation, and you also get advices and tips which will really help you. We have gotten students who have scored up to 313. We have gotten students who have scored up to 290 in the just concluded JAM UTME 2025. And talking to you, my name is Basi. I'm a 400 level medical laboratory science. I have students who are in 100 level medicine and surgery, 100 level medical laboratory science. I have students in School of Nursing Sciences. I have students, you can just mention the microbiology. I have students all over there. So as far as it comes to academic excellence, this is the perfect center. This is a solution center which you can rely on, right? So we are going to be talking about the separation technique right away, right? Separation technique, how we can be able to separate these what mixtures. What are the various ways? If I carry my ethanol, for example, and I put inside water, how can I remove my ethanol from the water since it's going to what mix? Right, it's going to what mix. How can I separate my ethanol from my water? Or what if sand now enter my water? How can I remove my water? How can I remove the sand from my water? How can I make my water what purify? Right. So those are the questions that the concept of separation techniques tend to what answer, and that is what we are going to be discussing right away. Right. So if there's anything you don't understand, if there's anything you don't understand when we're talking about the nature of matter, please feel free to drop it in the comment section. Let me know if there's anything you don't understand about the nature of matter, because right now we are done with the nature of matter and we will be moving straight ahead to separation technique. So we are going to be talking about the separation technique. Please subscribe to my YouTube channel. Please subscribe to my YouTube channel. Thank you so much. So let's talk about the master of the day. This is the master of the ceremony. MC, master of the ceremony. This is the separation technique. Let's talk about separation technique, right? Let's talk about separation technique. So with me here is where I jot down most of the points, because maybe there are some things I will possibly forget, and I will not love to forget it. So this is where I just jot it down so I can be able to get it. So when we're talking about separation technique, remember when I discussed about the element, compound, and mixture, it was in the aspect of talking about the mixture component. You need to separate mixtures into the various what components. So if we get a mixture, if we get a mixture, the only way we can use to separate these mixtures is by using what? A separation what? Technique. So we say this technique are techniques that use to separate mixtures into their various what? Components. Right? Now, what is the use of separation technique? Why do we separate? Why not just leave it? Let's leave it. After all, it's good, just leave it like that. Why do we have to now separate? We separate number one. So we say uses because of what? Purification. We want to make our substance or whatever we are doing the mixture, we want to get the various components to be what? Pure. So we say purification. That is one of the major reasons of what? Doing what? Separation of what? Separation. Right? Number two, it's because of what? Research purposes. Should I say purpose or purpose? Purposes, research purposes. If you meet all these phonetics people, research purposes. So it's because of research purposes. So you say research purpose. But me, I would say purpose, so because as a Nigerian boy, that is how we pronounce purpose. And all this phonetics is for rich men, children. Yes. So we say research purpose, and not just ending with research purpose. Number three is what? Analysis. So to analyze, right? To analyze this or various what? Substances or the various mixtures in the various components. That is a major reason we would undergo or make use of what? Separation what? Techniques, right? So we'll be stating right away with the different types of separation technique, right? So we'll be starting. Let me clean this because my board is small. Imagine already my board is big. I won't have been cleaning. I will just write. But now, as I write, I clean. As I write, I clean. So please just make sure you follow up. And if you are copying, please, you can. We should copy fast, or after I make this video, you can watch the replay value to see how, like to watch the replay, right? So I can pause and make sure you write everything down. All right. So let's talk about the different types of separation what? Technique. Now, as a village boy, I'm a big village boy. I grew up in the village. I used to go to farm. Right? If you have gone to farm before, drop it in the comment section. If you have gone to farm, drop it in the comment section. So as a village boy that used to go to farm back then, I used to go to farm. We do cassava, gari, right? So let me show you my gari. Let me show you gari. For those of you that have not seen gari before in your life, that are rich men children, let me show you gari. Call that gari, right? So let me show you gari. So like I said, I'm in my kitchen. So, rich man children, this thing you are seeing here is gari. So, this is gari. This is called black gold, right? This is gari. It's not harmful. It's food, right? So, let me go and turn it. This is my kitchen. So, this class is a practical class. Everything will be there. It's fun, right? So, that is just how it is. I'm coming. My mouth is dry. Let me drink water. My mouth is dry. All right. So that is just how it is, right? I am back now. Let me be back. I don't take style. Chop small gari. sorry. So let's talk about. I was talking about gari, right? So when we go to the farm, we harvest cassava. After you harvest cassava, you will peel, right? So you peel the cassava, you wash it. After you wash it, you take it to the engine. So they will grind it. After they will grind this cassava, you put it inside the bag and they will press it. Right? So there will be people that will press this cassava. Yeah, they will press the gari till it gets dry. Right? Now, after it gets dry, the next day you have to allow it to ferment. So the next day you go and carry it. Now, when you carry it, right, you take it to the fryer. The fryer is where you will fry the gari before it turns to this end product of what you are seeing here right now. So before then, there's something we used to say that time. We used to say filter. Gari. But as I grew up and I find out that we don't filter gari. Please take note. This is a very important aspect, especially for jam questions. You don't filter gari, you sieve gari. You don't filter, you will sieve. So we are going to talk about types of separation technique. I will be starting with the first one, Number one, which is what? Sieving. Now, what is sieving? I want to be very serious now. Because the spirit has descend. The spirit, you know, when you are there, how you teach, the spirit will not descend, you now go to another dimension. So now this dimension that I have now is inspirational dimension. So what is sieving? Sieving is a separation of what particles based on their what sizes. Is a separation. This is separation of particles. The separation of what? Particles. Now, it's not just based on the separation of particles, it's based on the separation of particles based on their different sizes. Based on their different sizes. Take note of this. Underline this. Underline this. Underline it. Underline it. Underline it. Based on their different what? Sizes. So when you're talking about sieving, it's a separation of particles based on their different what? Sizes. So back then, when we are filtering this garri, we have our filter. That's how we also call a filter. So we put this garri and we filter. It's that those particles that are smaller will pass through. Then those ones that are big, we throw it away. Right? Those ones that are smaller will pass through the hole, right? And those ones that are big will throw it away. This is because not all the particles are entering because of that stuff we are using, right? So that stuff has been able to separate these particles and not just separating them based on their different what sizes. Let's okay that there are some sizes that we don't want, while there are some sizes that we want. You get? So that is just how it is, right? Let's talk about the second one, filtration. Filtration. Filter. What do you understand by filtration? So number two, which is what? Filtration. So filtration involves solid plus what? Liquid. So we say filtration. Filtration. This involves what? Insoluble solids and what? A liquid. So it says insoluble solid. Insoluble solid plus what? Liquid. Insoluble solid plus what? Liquid. Right? Please take note of these key points because of I don't want my data to finish before I want to end this lesson. I don't want my data to finish, so I want to make sure I beat my data instead of my data beating me. Understand? If you want to support, you can support me. Can send me airtime, you can send me data. I will really appreciate, so that I will continue pushing. You can also support me by subscribing to my YouTube channel and also sharing my videos to your friends. You can share my videos to your friends so they can come here and get value, and in turn I'll feel motivated to continue dropping videos like this. So we say insoluble solid plus what? Liquid. Example is what? Sand plus what? Water. Sand plus what? Water. Sand plus what? Water. No, sand plus water. You pack sand and put inside water. Jesus! This guy don't pack sand and put inside water. Oh, I will make this water cleaner. You filter. You don't stress. At this particular point, you would filter. But now, there's where people used to get confused between filtration and decantation. Filtration and decantation. Let's write. The next one here is decantation. Decantation. Decantation, this one involves solid that settles plus liquid. Solid that settles plus what? Liquid. If let me show you an example. Let me show you an example because I want to cook. Oh, drop your account number. Oh my goodness. All right, my account number is my account number, I will go put 070. My account number is 7062462746. 7062462746. OP Basi Ejogba. Basi Ejogba. 7062462746. I really appreciate it, bro. Thank you so much. Thank you so much. All right, so we are talking about decantation, right? So let me bring my filter. Like I said, I'm in my kitchen today. So I'm in my kitchen. I'm just coming back from school and I will cook later in the evening. I was already cooking. I will have shown you the practical proof. Thank you so much, Donald. Donald want to support this live section. Please support, can help me. I don't need much money to buy data. I will really appreciate. Can also share my YouTube videos to your friends. All right, so now please, this is my account number. So now this is my filter. Like I said, in my kitchen, this class is an interesting class. I don't think I've ever had a class like this. So now decantation, I say it involves solid that what settles. After you cook your rice, right? You first of all parboil your rice, right? Now listen, you parboil your what rice. When you parboil your rice, what happens? The rice goes down, and the water is what up. Now you would decant. You pour the rice to the filter. You pour the rice to the filter. As you're pouring the rice to the filter, what happened? The rice settle. There's no how you will pour rice in a filter that the rice will now be pouring outside and water will not remain in the filter. It's not possible. Rather, the rice will settle in the filter and the water will now what? Pass. The water will not pass. What you are doing there, please take note. What you are doing there at that particular time, you are not filtering rice. You are not filtering rice. This is where Nigeria we used to turn everything upside down. That time that you are doing that stuff, you are turning your rice. It is not rice filtration. You are decanting. You are decanting. Please take note. You don't filter Gary. You see if you are what? Gary. Take note. You don't what? At this particular point, you don't what? Filter rice. You decant what? Rice. You decant. Because what you want to do is to remove the water. And the rice, the particles, the solid will settle. So decantation is used for solid that was settle plus what liquid. Let me go and draw my filter. This class is an interesting class today. This class is a very interesting class. All right, so let's move on. Ahead. Let's move on. Jesus. Jesus, Jesus, bro, Jesus, Jesus, guy, my head on boss, Jesus, bro, thank you so much, brother. Thank you so much. Like, I don't even know what to say. Like, I'm just lost of words. Please, everybody should join me and thank. Anytime you are watching this live stream, please, just join me and thank Mr. Donald. Please just tell me and thank Mr. Donald. Mr. Donald said I should manage it. What Mr. Donald sent to me is something that is more than management. Bruce, I really appreciate it, brother. Like, I really appreciate it. Thank you so much, brother. Like, this is more than amazing. I'm so happy. Thank you so much. Let's continue. The spirit is now moving. Like, so let's continue. Like, okay, my mic is on. All right. So we say what decantation involves what solids that what settles plus what liquid. So I say example is like rice, right? Pouring out what rice from what liquid. So when you pour out rice, you are not filtering rice. If you are talking about filtration, let me bust your head now. I just pray someone is watching me now. Let me bust your head when it comes to if you think you are filtering rice. What is it that even when you pour the rice, what is it that there is still sand? This is because it is not about the rice and the sand. What matters is any solid that can settle. that is what is going to remain. So if the sand can settle, right? If the stones that in their rice can settle in that filter, it's going to remain. So the canting involves or pouring out what rice from liquid, and the solid that must be poured must be those ones that will settle, right? So let's move on to number 4. Please make sure you are following. Our board is not big, so as you copy, I will be cleaning. When I read down, I'll clean. So make sure you are faster, you'll be getting everything. Let's move on to the next one, which is what? Evaporation. Evaporation. So the evaporation is like this. You put your salt. Mistakes happens, right? Mistakes happen. When these mistakes happen, these are things that happens, and mistakes are things we cannot avoid. Like, it happens. It no matter, you want to be careful, mistakes will surely happen. Now let's say you want to sip Gary, for example. You came back from school very tired, you are hungry, you put salt, you put water in a plate, and you mistakenly you want to pour salt, right? And the whole salt now enter inside that water. And you're like, Jesus, oh, my mother will beat me, or I don't get money buy another salt, oh, how I will take use salt. Now you don't have to be what? Confused. You don't have to be what? You don't have to be angry with yourself, or you don't have to be what? Afraid. What you simply have to do is turn that water that salt is inside, turn it inside a pot, on your gas or your stove or your firewood, cover it, allow it to boil to dryness, allow it to boil to what? Dryness. You allow it, it's going to what? Boil to what? Dryness, right? It's going to heat to what? Dryness, right? And when it heats to dryness, water will what? Evaporate. So I think my next video, if I'm unable to touch empirical formula, my next video I'm going to talk about change of state of matter. Then from this change of state of matter, is from then I will move to talk about, from the change of state of matter, I will talk about this empirical formula. Because it's very, very important you understand concept like empirical formula, the gas laws, molecular formula, relating molecular mass. In fact, all those calculations, as time goes on, I will make sure we trash them. They are going to trash all of them. So now, when you boil this water, when you heat this water to dryness, what is going to happen there is that the water will evaporate to the what? Atmosphere. So the water is going to go up, and what is going to remain there is your salt. Your solid what? Salt. So evaporation involves what? A soluble liquid. Sorry. No. Evaporation involves a soluble solid. So evaporation, soluble solid plus what? Liquid. Soluble solids plus what? Liquid. So before evaporation can take place, please take note, before evaporation can what? Take what? Place, that solid must be what? Soluble inside what? A liquid. What this means is that that solid must what? Dissolve, should be able to what? Dissolve in that what? Liquid. Like salt, there's no how you can put water and you put salt and you don't expect that salt to what? Dissolve. That one is normal life, like normal life stuff. Salt must dissolve in what? Water, right? So now there must be what? A soluble solid plus what? That liquid. So when you put a salt in a liquid, which is water, for example, it's going to what? Dissolve. And if we want to get back our salt, right, what we simply have to do is to what? Evaporate, right? So is to evaporate our what? Liquid, in order to get back what? That what? Salt, which is what? The solid. Now the truth of the matter is that we can evaporate this liquid, we heat the water to dryness, and the water will be going, right? So the water will be going, and we can also get back the water, and we still get back our what? Salt. What is going to happen is that, for example, if we are using kettle, let me bring my kettle, like this class now. Let me bring my kettle. So this is my kettle, right? So let me bring my kettle. This is my kettle now, for example. This is my kettle, right? So now this is my kettle. This is my kettle, right? So now I have put in my water and salt here, right? I want to heat it to dryness, right? So I cover it, and I want to get back my salt, and I still don't want to lose my water. I want to get back my salt, and I still don't want to lose my water. What I'm going to do is I'm going to heat it. I'm going to heat this water to what? Dryness, right? And in the course of heating this water to dryness, the water will be evaporating from what? Here, right? The water is going to be evaporating from here. What I am going to do is to apply what? Is to apply what? A protective what? Covering. So I'm going to cover here, right? I'm going to cover here, or if or something like a pipe. So when this water is evaporating, instead of the water to evaporate to the atmosphere, it is going to what? Condense. The water is going to what? Condense. So there's evaporation and what? Condensation taking what? Place, where we are going to get back our solids and where we're also going to get back our what? Liquid. Not just getting it, but we are going to get it in its what? Pure what? State. So that is just how what it is, right? So let's move on to the next one. Let's move on to the next one. Let's move on to the next one. Right? So we have gotten our what? Evaporation. Let's talk about the next one, which is what? Soluble solid from what? Liquid. So we say salt. Example, salt plus water. Right? So let's talk about the next one, which is number 5. Decantation. Sorry, no, centrifugation. I'm going to give assignment at the end of this video. Let me check out the time that we have covered. So I'm going to be giving, I will give an assignment at the end of this video. Exactly 1 hour, I'm going to end this live stream section, but I'm going to give an assignment, right? And that assignment is going to be focused on, you are going to tell me about distillation. You're going to tell me distillation. I'm going to write it down: distillation and the various types of distillation, and also separating funnel. So those are the 2 things you'll be using: distillation and what? Separating what? Funnel. You're going to be telling me. So I'm going to write it down for you. So what we have here right now is what? Centrifugation. Now this centrifugation is mostly used. This centrifugation is mostly used in we as medical students, especially not we as medical students, and those of us that are working in the lab as medical laboratory science, right? Scientists in future, in view, because I'm still a student. So now there are some tests you perform in the lab, right? So what they do is they take your blood. You see, they take your blood in the phlebotomy, right? Now put it in the what? Sample what? Container, and then now bring it to the what? Lab. Now before we work on that blood, because if we want to analyze anything on it, be it okay bicarbonate, creatinine, anything you want to work on, what we simply have to do is to separate that blood, the plasma from the what? Serum. We have to separate the plasma from the what? Serum. Remember what we are talking about, separation technique. We have to separate the plasma from the what? Serum. So what we simply have to do is to take that blood, those blood samples, in the sample container, and we put it in the what? Centrifuge. Right? So we insert it in the centrifuge. For those of you in secondary schools that might have not seen this, don't worry, when you enter the university, you're going to see it. So we put it in the what? Centrifuge, right? And we what? On the centrifuge from the power source or from the light source, and spin for a particular period of time in using a particular what? Speed. So we can spin at 3000 RPM for what? 5 what? Minutes. So when we spin, this thing is going to what? Spin. Now when it spin, that blood that was collected from you is going to be separated into 2: the plasma and the what? Serum. The plasma and the what? Serum. So now it's not left for us to take the what? Serum for our analysis, or to take the what? Plasma for our what? Analysis. So it's very, very important you get this now. So this test here is carried out we use a centrifuge in the hematology lab and also in the chemical pathology what? Lab. The hematology lab and also the chemical pathology lab. I think even the microbiology lab, we also use the word centrifuge. So this centrifugation is used for what? Suspended what? Particles. It's used for suspended what? Particles. Right? Because we want to suspend now, so we want to spin it in order to get our suspended what? Particles. Right? So we do what? Centrifugation. Please take note of all these what? Points that I am giving out here. So example, separation of what? You said separation of separation of serum from plasma. Separation of your serum from your what? Plasma. Like I say, this one here is based on what? Speed. Right? So it's based on what? Suspended what? Particles. Right? It's based on what? Suspended what? Particles. Now, tell me, I just say something now. Please, I just say based on speed. Yes, okay. The principle is based on speed in order to get suspended particles, right? Because I don't want to get confused. There's one thing I want to say. The next separation technique, before I will give you your assignment, I have an assignment. Do the assignment is not going to be something that is difficult. Do the assignment is not going to be something that is difficult. Just drop it in the comment section. Just explain, but make sure what you're explaining is something that you understand, right? So let's talk about the next one, which is the chromatography, and that is where we are going to draw the curtain. Chromatography, right? So let's talk about chromatography. 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 Now, chromatography is one separation techniques that always excites me. Although I don't know much about it, but I will give you the key points. It always excites me because I've not seen as they are doing it. Yes, I've not seen as they are doing it. I would really love to see how they are doing it. Chromatography. Chromatography. Is it chromo? Okay, chromatography. Chromatography. Right? Now, this separation technique, as I'm going to give you the word point, is used for the separation of what dyes. This for the separation of what dyes, pigment, dyes and what pigment. So is this for the separation of what dyes and what pigment? And you know that dyes and pigment, these are colors, right? Dyes, pigment, these are what colors. Example in what ink separation, in ink what separation. I don't know much about this because I've not seen it even in the textbook. As I'm reading it, what I'm just doing is theoretical. But I love when I read it and I understand it like I have seen it or experienced it before. That is when I really used to love it. But note, I want to give you key points. When you hear the term, when you are hearing about separation technique, and they're asking you which type of separation technique is used for, when you hear dyes, when you hear pigment, when you hear pigment, when you hear ink, and when you hear spit, please note that what they are talking about here is what chromatography. The moment you hear dyes, pigment, ink, and spit, please note if the actual separation technique is based on spit, please know that it's chromatography. It's used in separation of ink. It's used to separate ink, yes, dyes. Please just know that what they are talking about is what chromatography. So that is just it about separation technique. Although it's not done, you understand, we are not yet done with our separation technique. Like I said, our we still have our magnetic separation, which that one is very, very easy. Separate magnetic from non-magnet. And we also have our distillation and separating funnel. That is our assignment. So let me write down the assignment for you people. Let me clean it. Let me clean this. All right, assignment. Please, I'm not saying you have to do it much, but if you want to chat me up on WhatsApp, this is my WhatsApp number 07062462746. My account number is also there. If you want to support me, please feel free to support me. I would really appreciate it. You're 1,000, you're 200, you're 500, you're 3,000, you're 5,000. We really go a long way to keep me motivated to buy data. It's when I have data that can come online like this. And so when I see this money, I'll feel motivated, buy data, come online and share my knowledge. I'm not a gatekeeper of knowledge. When the moment I have a knowledge, it always excites me to share it with people. Well, so that is just how it is. So assignment, right? Number one, what is distillation? One, B, give the different types of what? Distillation. Then number two, yes, explain separating, sorry, explain separating what? Funnel. explain separating what funnel, and give instances where it is what applied. So this is just my little assignment. I don't have much. I don't want to stress you, right? So just do this assignment and submit, right? I don't want to stress you. Just do this assignment and drop it in the comment section at the end of this live stream, or anytime you are watching this live stream, anytime. So the first one is, what is distillation? We have distillation notes that my mind is scratching me, but I'm trying to hold my mouth because this is my mouth. Anytime I see things like this, my body is scratching me to answer it. So this distillation, notes that we have different types of distillation: the simple distillation, the fractional distillation. So what is distillation, right? Now give me the different types of, I've already given the answer, but now the different types of distillation, don't just list them down, try to say I can explain it. Now I know some people go to and use AI. If you want to use AI, you want to use a textbook, you are free to use it. But now the thing is that it's not just by using this AI. So ability, after you copy it and paste from the AI, make sure you at least you understand it, right? If it's like that, then who doesn't use AI? I use AI. If I don't understand something, I use AI. So AI is there. All right. So that is just the assignment. It's just that um MTN, sorry for the delay. MTN, I don't know what's wrong with MTN. MTN told me that my data is has finished. So you can see I'm using my hand now to hold this this phone. I don't know whether everything I've been seeing they have been recording, because I'm just the only one here with my phone. So I don't have someone who is standing behind the scene for me. So I don't know things, whether things were recording, because I was already done with this live stream section, only for me to come and check and find out that actually my live stream section were not, like, everything I was saying was not recorded. So like I said, that is just the assignment. Please do this assignment and submit. If you want to chat me on WhatsApp, that is my WhatsApp number on the board. Thank you so much once again. In case it didn't come up, I want to say thank you so much to Donald for supporting me. Donald, I really appreciate you. Thank you so much. I really love you. Thank you.